And we had the story about lines. So equations of lines is what we're gonna see in this section. We also graphed lines. We had a special way to do this, to use so-called intersections with various axes, x-axis and y-axis. Yes, with respect to the final exam, that's a very good question. Let's see what the calendar is, and I put this in the syllabus as well, but let us double check. So our semester is short and it ends next week. And that's great that you're keeping track of it. It looks like on 13th, indeed, on 13th, we have a final exam scheduled. So that's going to be next week, Wednesday. I scheduled it for the 13th, for just in case, to make sure that I get all the finals before Friday for sure, and all your work, so I could enter grades in the system on Friday. So the system I enter grades in is not Blackboard. Sometimes people think that what's on the Blackboard, that's very important. Actually, it's not, because the system to enter grades is totally different than Blackboard. So whatever I put on the Blackboard is just for your information, but it's not for the grading. Actual grade will be entered in totally different website. So it's a college website. So anyways, looks like we don't have much time left. We have this week and the next week on 11th, although the calendar I opened here says it's a holiday, but it is not for our college. I don't think Columbus Day ever been a holiday anywhere. So, but so we'll have homework from whatever we cover today and on Wednesday. So there are 2 more days. And then we're gonna be talking about the final exam, and I will send you practice final exam. And on the 11th, we're gonna do a review. So that'd be the plan. Now, also on the 8th, I don't think there'll be a class on Friday the 8th because I have to be at the conference, so no class on the 8th. So that'd be 1 day off for you. So it's good that you started to talk about the calendar, because I almost forgot, because they scheduled me to go to one conference, so I'm not going to be here. So I'll have to, it starts early in the morning, so I won't be able to run the class, but that's okay. 1 day is, I guess, fine, right? So anyways, what's the homework? That's a good question. So let me see. So far, we're in section 7.2. So today and next time I plan to cover, I hope to get into the end of chapter 7, but that's okay. If we don't, we'll see how it works. But you're right, we'll have chapter 5, 6, and 7 for homework. That's absolutely correct. So we didn't skip any sections, I guess, right? So we just went through those, and the part of chapter 7 that be assigned for homework, we'll see on Wednesday, next class meeting. So you will know for sure what be for the homework. But again, the plan is to get pretty much into chapter 7, but again, we'll see how it works. So anyways, I hope that's clear for now, and let us see what's in chapter 7, section 2. What we did, we graphed lines and we used special points of intersection with x-axis and y-axis. So let me try one exercise, let's say problem number 7. And to graph line using the intercepts, I need to have zeros utilized for x and then for y. So that's how we do this. So I'm going to be plugging in 0 instead of x. So my equation, which is 5x, is equal to 3y minus 15. Instead of x, we'll have 0 to get so-called intersection with y-axis. And then I need to solve this. So 0 will be on the left, and this is equal to 3y minus 15. So bring 15 over to the other side and have it equal to 3y. So I can see that y is equal to what? 5. 3 times 5, right? It's 15, so y is equal to 5. And this is my first point, the point on y-axis. I can actually plot this point someplace up here. It's called y-axis intercept. Point with y equal to 5 and x equal to 0. Analogously, I'm going to find the intersection with x-axis. So I'm going to take this equation once again, such as 5x is equal to 3y minus 15. And now instead of y, I'm going to substitute a 0 right here and find what x-axis intercept is. So I'm going to have 5x is equal to negative 15. And x will be equal to negative number 3. So this is our another point that we just found. Pair negative 3 and 0. And this is our intersection with x-axis. And we know since we just need 2 points to graph the line, then we have found enough. And we can connect these 2 points and get a line equation that looks like that. So intersections with the axis, with x and y axis, are very popular points because they clearly show how the line looks like. And to find them, all you have is just a 0. You have to plug 0 instead of x and then 0 instead of y. Well, the other thing that we can find about the line is so-called slope. Slope of the line. And to find its slope, there is a special formula that people use. It's a fraction that has difference in y coordinates on the top, y2 minus y1, and difference of x coordinates on the bottom, x2 minus x1. I hope you're familiar with this, but if not, well, here's the formula, and let us find what the slope is for the line above. For example, with first point x1, y1 is 0 and 5, and the second point x2, y2 where negative 3 and 0. So to get slope for the line that I just graphed, all I have to do is subtract y coordinates and then subtract x coordinates of those points. So y2 is 0. You see the 0 here, right? And 5 is y1. So y coordinates I subtract in my numerator of this fraction. And x coordinates I subtract in denominator. So it's negative 3 and 0 that I subtract on the bottom. And this leaves me with a -5 in numerator divided by -3 in denominator. So it'd be 5/3. And this is my slope, 5/3. So for the equation that we have here, 5x is 3y minus 15, we get a slope 5/3. Well, it turns out that I can take this equation and rewrite it. So what I can do is add 15 to both sides. So if I take this equation, 5x is equal to 3y, subtract 15, then what I can do is bring 15 to the other side. So I can add 15 here and here. So that doesn't change my equation. So I can write that 5x plus 15 is equal to 3y. And then I can find what y is. So to find what y is equal, I divide by 3 on both sides of this equation. Here, here, and here. So divide by 3 everywhere. And then I can write this equation such as a y on one side, and on the other side is 5/3 times x plus 5. So it turns out this is very popular way to write equations of line. And notice that slope that I just found, 5/3, is exactly what's multiplied by x. So the slope that we just found, the 5/3, right, is right here, multiplied by x. So this is the way that people like to write equations in so-called slope and y-intercept form, just like next group of problem is talking about. Please notice that 5 is also here. It's also y-intercept. What does that mean? Well, we just found the intersection points of this line with x and y-axis, and so-called y-axis intersection or intercept is up there. So there is a formula that section also uses. I didn't talk about it on Friday because the section looks like has lots of information. So, well, I guess that's extra thing that we have here. So I can try to find another slope here just for practice. Maybe I can do problem number 13. So look at the equation of the line in exercise number 13 and find slope. So the slope will be a difference in y coordinates divided by difference in x coordinates. So I'm going to mark these points as x1, y1, and then second point x2, y2. So there are 2 points here. And then I'm going to subtract the y coordinates and x coordinates. So I'm going to be subtracting y coordinates. They are -1 and 4. And then subtract x coordinates. They are -1 and -2. And this is the slope. So we have a numerator which is -5. And looks like in denominator, I'm going to actually have a plus sign here, right? 2 minuses mean plus. So that'd be 2 minus 1, which is 1. And the slope of this line is -5. So it looks like you can just use the formula and calculate the slope. Well, I hope this story is familiar, and maybe we can check out what's in the next section. So let me try to go to 7.3. That now talks about systems of equations. So they talking about solving 2 equations simultaneously. Like For example, in problem 1, what they do is they consider the system of two equations, and they are looking for variables x and y. So what they can do is take those equations and subtract one from the other. So when you subtract, the x's disappear. Minus 3y subtract y will give you negative 4y. And when you subtract also negative 4 and 4, you get negative 8. Negative 8. So I can see that y should be 2, right? Because when I divide, when I actually multiply negative 4 by 2, I'm going to get negative 8. 2 is going to be my y coordinate. And then to find x, what I can do is plug this 2 into any one of these two equations. So if I have 2x, let's say first equation, minus 3y is equal to number negative 4, then what I can do is replace my x with, or actually y, with number 2. So I'll plug 2 right here where y is, and find x. So I'm gonna see that 2x, why did it put minus 2? 2x minus 6 is equal to negative 4, right? So we add 6 on both sides, just like that, here and here, and find that 2x is equal to 2 and x is equal to 1. So x is 1, y is 2. So in that, they provided in this exercise a pair x and y, and it's like a point, right? X coordinate is 1, and that's exactly what we just checked out. And y coordinate is 2, so we just found it. So I've shown you how to not just check, but solve system of equations. And that's actually what we're going to do in this exercise. So that's what they like to deal with. They solve systems of equations. I can try to do the next example as well and then see what they're talking about here. So I can notice I can add these two equations together so that plus minus 2y will cancel. So we're going to have 2x on one side is equal to number 8 on the other side. And this gives me x equal to 4, because 2 times 4 is 8. Right? So I found x, and then what I can do is take my, for example, first equation, which is x plus 2y is equal to 2, and replace x with number 4. So when I replace x with number 4, I'd be able to find y. So looks like first step will be here to minus 4 on both sides, right? Minus 4 here and minus 4 here. So I'm going to have 2y's equals to negative 2. So y is equal to negative 1. So I have so-called solution of the system. And please notice what they did here on the left side is they graphed one line and they graphed the other line. And they noticed that point with coordinates 4 for x and negative 1 for y is exactly the intersection of these two lines, exactly point of their intersection. And this is not a coincidence. Actually, when you solve system of two equations, what you are looking for is the point of intersection of those two lines. And the reason that the point 4, -1 is point of the intersection is because this point actually belongs to both of these lines at the same time. In fact, we just checked that -1 for y and 4 for x worked for the first equation, because when you plug here -1 in the first equation instead of y, then you get x equal to 4. And you can also check this point into second equation, because to solve the system means to find point that checks in both equations of that system. And on the graph, the point is found, it's right there, so that's intersection of these two lines. So geometrically, when we solve systems of equations, what we do is we look for intersection points of both of those lines, which is very interesting thing to think about. So now I'm going to clean all that and move to the next pages where we have problems for practice. So let us try an exercise here at the end of the section. So here's the systems of equations. Let me clean this page first. Reshare this again. And let us just practice solving the system. So let me do, for example, exercise number 5 that says find x and y. And to find x and y, what I do is I add these two equations together. So my y's will cancel. And I'm going to have 2x here on the left side, which is the same as 8. And that's nice because now I can find that x is equal to 4, right? 2 times 4 is 8. So I solved this for x. And now I'm going to, let's say, use my first equation and find y. So in the first equation, I put 4 instead of x, add it with y, and have it equal to number 6. So I need to subtract 4 on both sides. Subtract 4 here and here. And see that y is equal to number 2. Just like that. So we solved the system and found x and y. When you say, Alex, but they actually say graph this system. That's how they want to solve this system. Well, I can also graph it, because turns out the graphing method of solving systems is not preferable, because it's sometimes very hard to see what the actual intersection is. So I'm gonna take this first equation and graph it. So it'd be x plus y is 6. So when x is equal to 0, so I put 0 here instead of x, and that'd be given me that y is equal to 6. So it'll be y-axis intercept of that line. So I can right away put this point somewhere on y-axis up here. 6. And then when I use 0 instead of y, I'm going to have x equals to 6, right? X equals to 6, so it will be someplace here on x-axis. So that's my first line. I get first line. And then I graph the second line analogously. So it's x minus y is equal to 2. So I'm gonna again use zeros for X and for Y. So I'm gonna plug 0 inside instead of X in here. And I get that minus Y is equal to 2, right? Because X disappears, so Y is going to be negative. Change sign, right? So Y is negative 2. Okay, so analogously, I'm going to utilize 0 instead of Y, and that will tell me X is equal to 2. So that's another point. So notice when I put 2 for X and negative 2 for Y, then this will produce the second line when I connect them, points. But to see what intersection is, it's not really that obvious, because when it says that, what, 4 or 5 or 3, well, the actual point of intersection will be with coordinates X equal to 4 and Y equals to 2. And that's what we just found. X is 4, Y is 2. But from my picture, it's not that easy to see this, because you need to be very precise and use graphing paper in order to realize what the actual pair XY is. So my advice is always solve the system instead of using this graphing method, because the so-called addition method is the most popular in solving systems. We just added 2 equations, right? That's what we did, and that's why the method is called addition. So I would say you can do all problems here on this page using the addition method. Just add the equations and see what you get instead of X, and then what you get instead of Y. Well, sometimes we saw that we, instead of add and subtract equations, like in exercise 10, I noticed that subtraction would be a better way to go, because when I subtract Y and Y, they cancel, and I just gonna get X here. So when I subtract X and 3X, I get negative 2X, right? And when I also subtract negative 1, it's gonna be a positive 1. So 1 and 1 will be equal to 2. So the idea of all these solutions is to eliminate, to cancel one of the variables. And I just canceled my Y variable when subtracted. So it is up to you to decide which method to use, whether you want to add or whether you want to subtract, because the goal is to cancel those variables. So now I can find X from here. So I can bring 2 to the other side. So I have minus 2 is equal to negative 2X, right? So looks like X will be number 1, because I multiply 1 by negative 2 and get negative 2. And once I solve this for X, I can find Y by just taking the first equation and replacing that unknown letter X with number 1. So it'll be Y is equal to 1 plus 1. So Y will be equal to number 2. And that's it. So I found pair 1, 2, which is a pair of solution of this system. Just like that. It looks like we solving this systems of equations, and our goal is to cancel one of the unknowns, either X or Y. One can look at exercise like 22 and say, Alex, how would you cancel your unknowns here in this exercise? Because looks like 2X minus X are not going to cancel, and 3Y and 8Y are not the same, so you cannot cancel them either. And it turns out that you need to prepare your system first. So what I need is to, for example, multiply by 2 my first equation. So the first equation here will be negative 2x plus 6 times y, and this is equal to 20. So I multiplied it by 2 because down below I have positive 2x. And then they will nicely cancel each other out, those negative 2x and positive 2x, right? If I add those two equations, one with the other. So if I add them now, my x's will disappear. So if you don't have same quantity of x or y, well, you should produce it by multiplying, as usual, entire equation by the same number on both sides. So now I'm going to have 14 y's here, which is equal to number 14. And that's pretty nice because it gives me y equal to 1, nice solution for y. So once I found what y was equal to, then I can use my first equation or the second equation. It doesn't really matter, it turns out, because in both equations you will get the same exact result. So I just copied my first equation here and going to replace y with number 1. So if I plug 1 here, instead of y, I'm going to get minus x plus 3 is equal to 10. And then I subtract 3 on both sides. Subtract 3 here and here. So my minus x will be 7. And x will be negative 7. So I used my first equation to find x. Well, you say, Alex, what if you use the second equation? Well, the answer will be the same. Look at this. If I take 2x plus 8y, and instead of y, we already know that we're going to have to use number 1, right? And then it's still equal to number negative 6. So you can find x from here. So you can just go 2x is equal to, looks like I'm going to subtract 8, right? Because 8 times 1 is 8. So if I minus 8 here and there on both sides, so we're going to have minus 6 minus 8, which is negative 14. So when I divide both sides by 2, it'll be, of course, negative 7, the same exact answer that we produced over there, right? So the point of story, it doesn't matter what equation you use to find your second variable. And keeping this in mind, I will solve all the problems in this section. And when I find one unknown, to get the second unknown, I will simply utilize nicer looking equation. Nicer. I say, Alex, how do I solve problem like number 15 exercise, for example? Well, in order to eliminate, I want to prepare my system to write it in a little bit better form. So first equation is x plus 3y is equal to 8. And the second equation, I'm going to modify a little bit. I'm going to bring minus 2x over on the left side and have it added with y equal to negative 9. So what I just did, I subtracted 2x on both sides. And the reason I did it is because I want to write equations in a form with x and y's on the left side and number on the right side. Because at this stage, I can clearly see how to continue, how to eliminate my unknown x. I just need to multiply this by 2, right? My first equation, if I multiply by 2, that plus and minus 2x will nicely cancel. So I'm going to have 6 and 1, which is 7y's here on the left side, is equal to 2 times 8 is 16 minus 9 is going to be a 7. And we have a nice answer. Y is equal to 1, right? So it looks like we're solving these equations by first preparing the system. First, we want to write the system in a nicer form so you can see what unknown is better to eliminate. So bring x's and y's in such a way that they sit underneath each other. And then you will definitely see what to do next. And now I can take any of these equations, let's say the first one, and pull out the other unknown from it. So I'm gonna replace y with 1, right? So I'm gonna have x plus 3y. So I'm gonna put 3 times 1 is equal to 8. And subtract 3 on both sides and find x. So it looks like x should be 5 because 5 plus 3 is 8, right? And we already know it doesn't matter which equation you use to find x, first or second. It is up to you. It doesn't really matter. So solving systems of equations is section 7.3. So maybe you can try one for a little quiz, like exercise 6. Quiz for today. Please solve the system, do exercise number 6. So find what x and what y are equal to. I'm going to stop recording at this stage.